at this point, you guys have got to get me stopped to say around 5:05. You will have two homework assignments. One, I could have posted on Friday. You have all the information, but I thought you would bomb a part of it that's really kind of important, and you'll be able to get that from today, even though it's a one sample test for the first homework. But as a result, you're going to have two sets of homework which are due next Friday. There's no point of having you turn them in early because I'm not going to grade them until, let's say, Saturday, Sunday morning. So we'll do both of them on Friday. But I do want to take a few seconds to make sure I walk you through what it is and why we're doing it, blah, blah, blah. Then you have that. You can start work on immediately. You can turn it in early. No one's stopping you there. But a second homework should open up this coming Friday, which means there'll be two at the same time. Make sense? Questions with that? Okay, so we are now on our second step of 1 and 2 sample tests. One sample tests are actually really kind of cool and very underutilized. And I don't think I would ever publish with it, but I like them because I'm able to do sort of quick things that allow me to get a sense of the data, allow me to play around with different null hypotheses, and therefore, in some ways, kind of a poor man's Bayesian to just sort of play through what seems to be in line, what seems to be consistent, what doesn't seem to be consistent, because you normally define those null hypotheses based on biological reasons, right? Two sample tests are probably our first very traditional type of test. And there's good information from Mitulsky and Dalgaard. Mitulsky, again, required-ish reading, and I really do encourage it. Good writer, good concepts about statistics, not writing from a traditional statistician's perspective, really writing from a biologist's perspective. He also writes from more of a medical perspective, where in this class, we definitely talk through an ecological perspective. So those are good. Okay, so I realize I'll show you an equation. You'll be like, yeah, no, that actually does look like Greek. I will argue it's the exact same structure of what we saw with the one sample test. And it will be a very similar structure to a lot of our Popperian approaches. It's the same basic idea. You are looking at differences between central tendencies. In this case, you are looking at the difference between the mean of the first sample relative to the mean of the second sample. Think of it as two outcomes in a grouped categorical variable. So maybe one is wild areas, the other one is urban areas, and X bar 1 is the mean of the wild areas, and X bar 2 is the mean of the urban areas. Maybe think of it as male and female, where X bar 1 is the mean of females, X bar 2 is the mean of males. It is the difference between the central tendencies of two groups within a category relative to their variation, where what we're looking at is the standard error of the mean squared plus the standard error of the mean for the second population squared, and then you take square root of that sum. The math has structure, and the math has structure because it fits into the calculus of a normal distribution. Just like a one sample test, you are calculating a test statistic. You are evaluating that test statistic relative to the degrees of freedom. That's what gives you the p-value. The math, whether it's square rooted, whether it's squared, is not really of interest to us in terms of what it is doing for us. What it is doing for us is allowing us to compare our central tendencies relative to the population's variations. That's what it's doing for us, which is really the exact same thing we were looking at when we looked at the one sample test, where you're there, you're looking at the central tendency of what you measured relative to the null hypothesis central tendency over the variation. Same basic idea. Make sense? What I want you guys to do is two things. Part of that, I say there. I want us to take 3 or 4 minutes. I want you guys to write this out in English. So I've said it all, but I want you to write it out in English. The second thing I want you to do is I want you to tell me when t is going to be high and when t is going to be small. When is t going to be a large number? And when is t going to be a small number? And then for bonus, if you get done early, tell me whether sign matters. Does it matter whether it's positive or negative? Thank you. We good? We know what we're doing? Cool. One more time. Okay, it's a good start. Jamie, let's build on that. I think that is a nice improvement. The difference between sample and means. Like, wait, okay, so you said this so cleanly. I like this. The difference between sample and means. So what you're saying is fair. It's the group standard errors. So someone can simplify this whole concept, make it a little bit more simple. Okay, could someone give me maybe a more simple approach to how we describe this part? And what I'm cool with that. Does it go to all the details of the squaring and the square rooting? No, no, no. In fact, if you really want to sort of take out the mathematical jargon, I'm okay with putting in this relative to pooled variation samples. I like exactly what was said. I think exactly what was said was great. I just tried to take out all the mathematical jargon. So really just getting to the core concept. What was said before, perfectly accurate. If you want to add in the pieces about squaring, there's a reason for that. If you want to add in pieces about taking the square root of those sum squared terms, there's a reason, logic for that. Most of it is to create that curve. The square root is actually to put it back on the same unit as the central tendencies. But in terms of sort of getting the overall concept, perfect. Love it. So, Jordan, when would I get a large T? T which is large. Give me one case. When the differences between the means is small, that's going to give you a large T. Okay, but let's think through it. So if the difference between these two numbers is small, it's going to be large. When the difference between the two sample means is large, you get a large T. You get a small T when the difference between the means are small. Remember, what is this test doing? This test is comparing two samples. The size of the T is actually an indicator of how big that difference is. What about the variation? How would that contribute to the size of T? When would T be large? When would T be small based on the variation? And for that, Ashley. When is T going to be large? What's going on with the variation when T is large? Is there a lot of variation or very little variation? Little. T is going to be large when there's very little variation. And you can kind of get it. Then really it's just essential tendencies that explain the difference. T is very large when the variation is small. And T is very small when the variation is large. You can kind of think of the variation as noise. So you look at the differences between the central tendencies, and then you are looking at that relative to the noise. When there is a lot of noise, that difference doesn't mean much. When there's very little noise, that difference means a lot. And that's why we're looking at both of these properties when we are looking at statistical comparisons. We're looking at our measurements of our central tendency relative to our variation to figure out how big is that difference for real. It's a huge difference when these differences are large and that variation is small. There's no difference when the differences are small and or that variation is large. It might look like difference, but remember, that's one of the things we use stats for, is to help us discriminate when we can see a pattern versus what is a real pattern. In some ways, you can think of the variation as keeping it real. And that made me personally giggle, but that's okay. Now I have one last question. Does sign matter? This one's just a little geeky math thing. Does sign matter? When T is positive, what's going on in this equation? When T is positive, it means the first sample's mean is larger than the second sample's mean. When is T going to be negative? The opposite. When the central tendency of the first sample is small relative to the central tendency of the second sample, and T is negative. Which sample should be first? Which one should be second? It literally doesn't matter. Now, if you want to, and you're setting up stuff, maybe you want to make the big one always first. That's fine. That's fine. But it literally doesn't matter. And the computer is just going to do it and not care. It's just going to do it. And normally it's going to do it based on alphabetical order. So if you are comparing aardvarks versus zebras, that's the aardvarks, right there. And that's your zebras, right there. COVID, Zika, it doesn't matter the sign. What matters is the size of T relative to the degrees of freedom. T is going to be large when the central tendencies are different and the variation is small. T will be small when the central tendencies are similar and the variation is large. And that's the core concept behind it. Now, you're going to report the T. I appreciate if you understand the logic behind the T, you will be required to be tested on that. I mean, but then after that point, if you forget that issue, never remember it, that's fine. I'm not going to fight that one. But that's the logic behind where that number comes from. When we do statistics, just as a reminder, real quick reminder, what is the first thing that we start with? What do we pay attention to first? You run a test, and what do you pay attention to first? P-value. Once you make a decision about the p-value, do you care about it anymore? Nah, you move on. There's much more exciting things. It's just a starting point. This helps us get to that starting point. Cool? Well, this just seems to always be timely. Hurricanes. I don't know, maybe you've heard of them. This is Harvey. Harvey dropped the largest amount of rainfall in a 24-hour period in Texas in recorded history. It's a 100-year storm. We just had a 100-year storm. Harvey was like 3 years ago. I don't think we know what 100 years means anymore, but whatever. Atlantic hurricanes. Atlantic's always been just a beautiful incubator for hurricanes. And there's a lot of work trying to figure out if there are changes in the frequency, the intensity, the size of hurricanes. Because hurricanes suck. And I know you know this, and I know we've all appreciated it. And I truly hope that you escape the worst of it. But one of the things that we're trying to do always is get a better sense for these storms. And we are getting much, much better sense. This most recent hurricane that hit us, Ian, when did you start tracking it? When did you know to start tracking it? Unless your name was Dr. Melody Eichbauer from the history program, who didn't quite realize there was a hurricane until that morning. But that's an editorial comment that's really not for you all. It is for Sean. Idiot. It does make sense. When did you all start tracking it? Friday? When could you have started tracking? When did we start to know that this is a hurricane we need to pay attention to? Yeah, it was about a 10-day period. About a 10-day period where they identified it as the potential. It's going to start emerging in 10 days, or 5 days is normally that time span. And that sort of very preliminary possibilities could put it going from where it was in the lower Caribbean up to a more northerly environment, which meant us. When did it start to look like it might be coming to us? I think that's your Friday, your Thursday. And then Sunday, Monday, punk, this little psych thing said, no, don't worry about it. I'm going further north. It's fine. Do what you got to do. We actually came to school on Monday. I literally thought we were going to come to school on that Tuesday, knowing how slow our school is to respond to these things. And it was sort of playing with us. It was teasing us. And I said, no. I told you where I was coming on Friday. I am coming back. And it came back. And he was a jerk. But that happens. But we want to understand these things. And one of the things like big data is we have really good records of them. So what I want us to do is start by downloading the hurricane data. I want you to open up the Excel file. That Excel file tracks all identified hurricanes from the late 1700s up through 2020. All of them. It is a complete exhaustive record identifying the frequencies of known hurricanes in the Atlantic basin. And that, I want you guys to have conversations with each other and Zoom in. You guys got to start talking to each other. What is old and what is new? Because what I want us to do is I want us to address a central question, and that is are we seeing a change in the frequency of hurricanes? And to do that, we need to know what is new, and there should be a good logical reason for it. And we need to know what is old, and there should be a good logical reason for that. We should also figure out what data should be included in any analyses and what data needs to be excluded from any analysis. Cool? Questions? All right, get on. Okay, so let's take a half-a-minute break. Because one of the things, and every time you look at data, you should always start with this issue. Oh, cheeky. I like that. In case you missed that, I said you should always start with this issue. Lucy says, take a break. Well, I guess I'm not showing you. I thought I was showing you a screen. So you should always start with the issue of what is the data? Even before you're able to address new and old, you got to know what the data are. And we need to know what the data are because the data will influence potentially our definition of new and old. The data will influence the type of questions that we may want to address. So we start there. Is your data. All right. So year, pretty straightforward, right? Any questions with that? What's the difference between number of tropical storms and number of hurricanes, Seth? Intensity. Okay, so we have the number of tropical storms. We have to hit a certain level. What is that, 35 sustained winds of 35 miles per hour? Roughly, approximate, okay. And then hurricanes, is that roughly 72 miles per hour? Sustained, what's that? 75, okay, okay. And then of course we have the next column over, which is number of major hurricanes. So I think I'm gonna have you finish off that last one. A lot, yeah. I mean, more. And for Ian, our most recent namer, that was a major hurricane. No question about it. So I like that. So we have these estimates of intensity. Does this mean that there were 21 identified storms in 1850? No. Tropical storms will always be the highest number. All the tropical storms could be hurricanes, and therefore there'd be the same number. All the tropical numbers could be both hurricanes and major hurricanes, and therefore they'd be the same number. But it's just as reasonable to say that there might be 10 tropical storms, 2 hurricanes, and 1 major hurricane. That means 10 storms all over. 8 of them were just tropical storms. 2 of them became hurricanes. And there's 2 that became hurricanes. 1 of them was a major hurricane. Brilliant. Dominique. Accumulated cyclone energy. What do you think that might mean? Yeah. Individuals or total? Total. So basically it takes the amount of energy identified in each of the known storms and provides a total amount of energy from those storms. Can anyone think of what this information might give you that you don't necessarily see in the frequencies? That gives you an overall estimate, yeah, of the actual total energy on it, which you don't get just by knowing how many storms there are. There's a big difference between Ian and a tropical storm. We got hit by a tropical storm this year, right? Yeah, that's the way you know whether you care about a tropical storm or not. When I asked the question, we got hit by one. Well, I'm not totally positive. I think I was in Peru, and the answer from you all was, did we? They're kind of rainstorms. In fact, in some ways, it kind of feels like we get a tropical storm every afternoon in the summer. They're big rain events. They're cool. We like them. Yay. That's fine. Very big difference in terms of the actual hurricanes and major hurricanes. This gives us some total of that entire cumulative energy. What would, Haley, the next number give you? Yeah, why is that might be an interesting or important number? I'll tell you about the physical damage. And of all the things that we want to know in terms of the effect of these storms, I would probably argue this would be the one we're most interested in. How did people survive? And when we have problems, what do we need to do to adjust those problems so people survive? You know, that's the highest priority, I would assume. And then this last one, Gil, what is this giving us? G. Total monetary damage. And Gil, what would you want to know about that number? That would be important for you to decide how to understand that number. Okay, so that might be something we can infer, a little bit like a different way of thinking of death as the total amount of damage. Is there any difference between 10 deaths in 1970 and 10 deaths in 2010? Is there? Damn, you guys are going in a way I was not expecting. I'm still listening, and there's a lot of little comments going on. So someone walk me through that out loud. You guys are doing really well. All right, all right. Damn. Cool. All right. So I'm still going to go back to my monetary question with Gil. I'm not arguing. I think you guys made a good argument. I stand corrected in my thoughts. The same amount of $1,000 in 1970 versus $1,000 today. Now, I think my parents' car back in the 1970s cost $3,000. And it was a race car. It's a little Karma gear, tiny, it's fun. Could you get that today? Could you get that exact Karma gear even today? No. So one of the things you're going to consider when you're considering versus recent modern hurricanes versus historic hurricanes is also the data. I just have hurricanes changed. These are data. You want to think about which of these data make the most amount of sense to address that question and how that might influence your decision on what is recent, what is historic, and have these storms changed. Some of these variables might be appropriate for this question. Some of these variables may not be appropriate for this question. One of the things that I think we would need to figure out is whether monetary damage controls for inflation or not. Because if it doesn't control for inflation, it doesn't make any sense. If it does control for inflation, then it might be of interest, might be of meaning. So they saw the number of known hurricanes in the Atlantic basin. So this would be anywhere a hurricane could form and or make landfall. Dominique and then Connor. Really? That's kind of cool. That's kind of cool. Well, I hope she was fine. And yes, she survived. So that's also good. All right, Connor. It will. It will. But that's a little bit ahead. We'll get there. We'll get there. Oh, Victoria, yes. So what does this feel like? Does this feel like it's controlling for inflation or not? 8,000 deaths, but only $60 million in damage? This is not control for inflation. Yeah, just a heads up. This is not control for inflation. And that is one of the things you always want to know when you are playing with numbers is what exactly those numbers are doing, because then that helps you make a decision of whether you actually want to pay attention to them or not. This number, this does not control for inflation. Deaths, I think you actually just made an argument, does not control for population size in ways that I had not considered, where I would have think before you maybe look like an idiot, I would say deaths would be a standardized thing that you can compare across periods of time. Seth? So every single tropical storm in 1895, two of those tropical storms became hurricanes, and none of them became a major hurricane. So this actually tells you how many storms were known. Of those known storms is how many became hurricanes, and of those hurricanes is how many became major hurricanes. Okay, so you now still have your two tasks. Your two tasks are what is recent, what is historic, because our question is, have things changed? That's our question. Second, you need to determine what data are usable and what data are not usable. And both of these have got to be logically sound arguments. There's no exact right answer. There are definitely wrong answers. Cool? Okay, let's get back to that question. Okay, Nick. Data from 1850 to 2020. What's recent? What's the range for recent? All right. All right. Let me go get the right data set because that was not right. Let me find the data set. 1937 through. Okay, talk to me and explain that one. Okay, Nick, what are you majoring in? And what type of biologist are you? Cool. How do you just decide a cool ecological question? No. I just asked, how did you just decide on a cool ecological question? You have 2 minutes until class is over? Oh God. But oh, you'd be surprised. I mean, come on, you know me by this point. Okay, so someone walk me through that. Why is that a problematic range? Oh, I'm so sorry. You did a great job. I'm asking everyone else. Why is that a problematic range? It's making a bunch of assumptions. What assumptions are we making when we establish a range based on evenly distributing our data sets between our two populations? First thing, what's driving that decision? Because it's a fair decision. And there are many academics on this campus who would make it. I'm going to encourage you guys not to. What type of academic would make that decision? Mathematician. Mathematician would look at the fact that you have a particular population. It would be easiest mathematically to divide it. Now, what could be driving an issue like changes in the frequency or the potential damage associated with a hurricane? What could be driving the issue in terms of frequency? Non-rhetorical, open floor. Temperature, climate change. What could be driving an issue of damage? Inflation, development. Both of those could have very interesting things to consider in terms of this question. Let's go to these data. And I opened up the wrong spreadsheet. I apologize before. Here we go. We have everything. Are all of these data equally good? Let's start with that. Okay, so where do you expect to have the most reliable data? Would you expect to have, Dominique? 1960. Cool. I did not know we were going to get an exact number. I love that. So I'm going to highlight it. What's that? Yeah, I was going with the most reliable. Oh yeah, no, fine. I'm going okay with that. So let's actually start with it. So you answered a different question. Let's use your question. So when would we expect to maybe have some of our first reliable data? You said 1960. Why? Weather satellite. Okay, so what is it about weather satellites that could be important in terms of our knowledge about hurricanes?
If a hurricane comes and never hits the land, was it ever really there?
If a hurricane forms and it never hits any land, was it there? I love it. You guys just have your new forest in the tree argument in terms of sound. That's perfect. But in many ways, prior to the advent of satellites, that's reality. We don't know. I mean, you could potentially pick them up by airplanes, transatlantic airplanes, but you could miss them. Presumably with weather satellites, you might catch them. Do you think those would be good weather satellites back then? Well, that's better than what we were recording before. Absolutely. You ever all seen an old TV? Are they good? Are we using the same definition of an old TV? I'm not going to ask that question. What's that? Yeah, very staticky. Have you ever been with a TV where someone had to stand by the antenna, hold it to keep it signal? Yep, sure. All right, so you're making an argument that this might be a starting point because of a historical event where we had significant damage as a result of a hurricane, and therefore people were very keen to start knowing. That's fair. What assumption is being made in that argument? Oh, true. I get that. I get that. But as a starting point of reliable data, what assumption are we making? Okay, so as soon as we start counting, we start paying attention, right? Y'all seen Hamilton? Yeah. What's the first song? Why'd he come to the United States? Oh, so disappointed. Hurricane wipes out his town, kills his family, comes to the United States, starts anew. We now have money. Hamilton, the musical. That's it. It's richer than that. See it. When do we have to start with reliable data? I would probably make an argument 1938 is not reliable data. I'll make a few assumptions about that. One, yes, it was a big storm for the United States. The Atlantic Basin is much larger than the United States. Just because we might be more interested in keeping records, that doesn't mean Grenada, as an example, is keeping records. They may be keeping records, but it also doesn't mean that we're exchanging records. So you might have records down in Trinidad and Tobago, you might have records in Cuba, you might have records in Florida, they're not maybe being cumulative enough. I like the idea of a satellite. Is a satellite at those times comprehensive? Like how many satellites do we have up right now for our weather system? We have a ton, constantly monitoring the skies, constantly monitoring the situation. Are all of these data equally solid? So we need to start where we think we're comfortable with the quality of the data. I think, Dominique, you gave us our first idea. Are people comfortable with data after 1960? You all comfortable with that? Any arguments for that? All right. So we are going to do the great, wonderful thing. We're going to highlight that, hold down the shift key. We're going down to, oh, sorry, skipping 1938. Going down 1959. Sorry, Elvis, you're gone. We're there. By the way, never do that with your raw data set. As soon as you do that, take your file, save it. Save it as. So 1960 down to 2020. As soon as you delete information in it, save it as. Where is my stuff? And save it as a new name. What I would save it as is hurricanes _ 1960 through 2020. What's up? So it's a good question. Why are we deleting data before 1960? We don't trust those earlier data because they're being collected. Not that they're bad collections, they're just probably missing out on a lot of information. Whether it's being collected by human records, whether it's being collected by atmospheric records, whether it's being collected by core records. Like people know Dr. Mueller over in the water school. She does great research by taking core samples from our beaches and identify storms that occurred hundreds of years ago by a pollen layer or by changes in the soil composition within the sand. Is able to identify when these storms came in and degree of their intensity. That's good, but it doesn't give us comprehensive information. So I can't address the question we're dealing with here. Okay, so I'm changing that to 1960 or 2020. Great. Now we need to know fine. We need historic and we need recent. If we're thinking about this as an issue of development, when does the recent period of development occur? If we're thinking about this as an issue of climate change, when does the recent period of climate change really start? And there should be, again, a logical reason. The reason it's not acceptable is just dividing the sample in half and making half of it historic and half of it recent. So, Misty, what's our flip? What's a good beginning period of time for either climate change to identify historic versus recent, or development to identify historic versus recent? Great. And I like that. If you're not doing it, that's smart. Find some evidence, find some information. It sort of allows you to stand justifiably by your statement. As soon as someone's got something, go ahead and yell it out. It's interesting. Gore, Al Gore. The almost president of the United States, except for Florida. We're awesome. How about some others? I think Gore might be interesting. So the argument here is that this is when climate change started to gain very widespread attention because of a documentary that became popular and many people became exposed to the issue. That's interesting. No, that's interesting. What's another one someone came up with? Zoomland, in person? I don't know. You haven't told me yet. Okay. So someone's going with either Prince or Y2K. And you may not know either reference, but one, 1999 party, or two, Y2K, when we all thought the computers were going to crash because we were using 2 numbers for our years instead of 4, with the assumption that the first 2 numbers, 19, were part of every code. And all of a sudden computers wouldn't operate because they no longer knew what to do. They were going to revert back to 1900 instead of 2000 on January 1st. It literally caused a tremendous amount of panic, and people spent obscene amounts of money to fit code. But it also spawned one of the best movies ever in its form of Artless Space. Is that a good one? Okay, I'm getting a head nod. Yes, it is. More. I want more. I want at least 5 to 10. 1975. Why? All right, that's determines that might be an inflection point in terms of changing frequencies. Now, that's when you start to see steady increases. Does that mean it's increased? And then from 1985 to 95, and 95 to 2005. So when does it increase? So you're going for the inflection point. Great. What I'm asking is the inflection point is starting point, or should be when we actually start to see higher temperatures. I like it though. So that's 3. I gotta want at least 2 more. Walk me through that one. It was a bad event. It was a very bad event in those locations. It didn't go past those locations. There were major volcanoes. There was the one in Iceland that actually did have a continental effect in Europe, but not global. Why? Okay. So that would be particularly for development. That's interesting. So if we go development, that might be an argument. There was the very famous El Nino that put the phrase El Nino on the map and really changed much of our understanding of not only the Galapagos, but how rapidly evolutionary biology occurs. So it's a very important scientific year, was that 1992 El Nino event. Now, but is El Nino really part of the issue of hurricane? Okay, okay, I like it. I like it. How about 2 more? La Nina is the opposite. So it's where the southern oscillation occurs, and then how that southern oscillation. So the southern oscillation is an area of unstable weather with a lot of thunder, lightning, rain that basically moves back and forth along the equator. Where it positions, in one position is El Nino, I want to say that's further to the east. The other position is La Nina, that is further to the west. That's what ends up changing the ocean currents. Connor? Ozone, okay. Yep, ozone was bad. That's back when we all had the Jersey hair and people would just spray to make it go straight up. Those are gone. 2004, why? Yeah, that's when we had lots of hurricanes. Charlie for this area. Francis, yep. Lots and lots of them. Okay, so we have quite a few options. What I want us to do is I want us to decide between those what is one of 2 things. If we're going to go for the climate change, which is the most scientifically relevant to identify as a switch? If we're going to go for development, which one is the most economically relevant to decide a switch? And that'll also influence what data we use. Okay, so I'm gonna give you guys a minute, discuss, talk, and then give me a consensus. All right, I want consensus. What are we doing? Let's do first consensus. And it's just by show of hands or voice or whatever. We're gonna deal with development or we're gonna deal with science. Okay, thank you. You guys are all scientists. I did appreciate that, but I was also cool with development. Great, Andrew's out. So based on that, what is our point that we're gonna sort of reference as the difference between recent and historic? Why? Okay. And that might be a fair argument. You're seeing an inflection point, 1975. You give it a period of time to go through a cycle and then start to look to see if we get a change. Now, do you want to keep the data from 75 to 85? Or do you want to eliminate that based on the idea that it's a buffer and it may not actually be reflective of changed events? Of course it is. Okay, so we're gonna do 1985, and we're gonna do everything before 1985 as historic. You're gonna wanna do this for your data. And everything after that has recent. I like that. Based on that, are there types of data which we are not going to use in this study? What would be some of the data that we're not going to want to use in this study? Probably not monetary because it's not adjusted for inflation. What's the other one we're probably not going to be interested in this study? Could be, maybe, maybe not. I can see one that's pretty definite not going to be of interest for the way you guys argued already, and you convinced me. Death. Way you guys argue about death, in fact, that it has to do with the number of people, has to do with the degree of development, the type of development. Yep. I think that one also doesn't make sense in terms of this comparison. What I want you guys to do now is I want you guys to take your data, upload another copy for you on Canvas if you didn't make the adjustments to the file. I want you to get that into R. Have we done select? We did select. I want you to select out the data we're going to use. I would encourage you to change these names. I would encourage you to make that tropical storm, hurricanes, major hurricanes with no space, your choice. I would encourage you to make this energy for accumulated cycle energy, just make it energy, your choice, but get it into R, select out the correct data, and then make time a factor. All right? That I think should probably take 3 to 6 minutes. The cycling energy is actually just a description of the hurricane, not the economics. B. Okay, I updated the hurricane file as an Excel file in Canvas if you want to take it. It's the same one that you see on the screen. It's Excel file, so you're gonna have to make the appropriate adjustments there.
They do, but I wonder if that affects that should. So I guess it would be fine for this. Yeah.
Well, it does, no, but just for what you have, it's kind of interesting. What is the x-axis supposed to be? Is it the dependent or different variables? Is one having influencers? Y variable. So this one is figures. Yeah, is that the right way? Yeah.
So I'd really encourage you guys to get the practice of get good code. Once you get good code with good notes, copy and paste it, and then make the small modifications you need. Up on the screen, I do have the introductory code for getting your data in there and manipulated. For select, instead of selecting variables, I told the computer which variables to drop. And I did that using the minus sign in front of the variable name. So I didn't want to write out all the names of the variables, because that struck me as boring. So I just identified those that I don't want, and I just said minus and put down their name. Oh, good choice. About one more minute. Again, you can check your code from what's up on the screen. If you didn't manipulate the Excel file in Excel, just grab it from Canvas. I deleted the previous version, upload the version you guys just created. So it's there, but it is an Excel file. You have to convert to a CSV. If you're really keen, try to figure out how you subsample a spreadsheet so that you can put in the original spreadsheet without any of the manipulation we did in Excel, change variable names, and only subsample from 1960 through 2020. It is doable, and you do it in Tidyverse during this period of mutation select. So it's only if you got to this point. If you got to this point, then you geek off and you try the next thing.
Can you add like a recent and historic that hash? Like adding a new column?
Yeah. That's actually true coding. Just low, not much. Just low real coding. Do y'all know what true coding is? Again, if you're still working on this, you work on this. You guys know what true coding means? Versus what we're doing here? True coding is when you create a function within the code to do something. So when you're in Excel and you do an if-then statement, that's true coding. It's simple, but you just give it a rule. You tell the computer to follow the rule, and if it follows the rule, do A. And if it's a different rule, do B. No big deal. Same type of thing. You just do sort of an if-then statement here, where you tell the computer any sample, any year, before this number becomes historic, and a year after this number becomes recent. Yeah, very doable. All right. Oh, that was a lot of boring video. I didn't pause it. Yeah. So we bring in our data. I'm just keeping the exact same packages from before. I'm just copying them out. I may want to check for normality because that's always a good thing to do. So I'm on my QQ plots. So I grab car. We have Pacman. We have Tidyverse. We have car. We're actually going to be using Tidyverse more completely today than we have been using in the past. Up until this point, Tidyverse has just been for the piping. I'm grabbing all my data. If I didn't have it here, I've set up my new project. My project has data. It has, data. It has, nothing in code. That's weird. It has output, but doesn't have code. I don't understand that. I do have data. I've written out data. I then tab. It brings in, yes, CSV if that's the only thing. Otherwise, it gives you a drop-down menu. You pick. I run it. I get my summary. There's a lot of information in the summary. I'm going to make this slightly smaller. That's great. But I got this stuff that I don't need. I mean, monetary damage is cool. And depth is cool, but those are both economic variables, and we're just going to deal with the science here. So I'm going to want to get rid of those. I look over here. Day looks like it went in. Historic, year, storms, great. But when I look at the summary is a little weird. Time, it's identifying as a character. I actually don't see historic and recent as sort of identifiers. So I go back here. This is where we use our Tidyverse. First thing I'm going to do is select. And notice I'm using this minus sign. With a minus sign, I'm telling the computer, find that variable, don't include it. So we're going to include everything that doesn't have a minus sign. And you can mix them up. You could have no minus and minus. It gets a little weird, but I'm just like to keep it simple. I didn't want to write out 6 variable names. That seemed boring. Writing out 2 variable names with a minus just seemed quicker. So I did that, minus deaths, minus monetary damage. Why these stupid, weird little 4 quotes? Why? Because I got the 2 words in that space, and I doesn't know what to do with spaces, and I should have just given rid of space, but I didn't see it. I didn't pay attention. So I got to do the quotes. Oh, well. And then we have this line, time as factors time. Monetary damage doesn't exist. That's awesome. Oh. Well, I don't know where its ego, so I'll have to look it up. Oh. Thank you all. Oh, look at that, it worked. I go up here because again, I was like a little anxious. I want to take a look. It's all looking good. All the data I want, numbers are numbers, all the stuff. But I like to do the summary anyways to see it. And that's good. Yep. Oh, there's my time. I got historic. I got recent. That's cool. And then I do this attach. Why do I do this attach? What do I do? Line 17. That's it. Nothing more than that. You don't have to do it. And when you are using more than one data frame at a time, and there will be reasons you use more than one data frame at a time, don't use it when you use more than one data frame at a time. But if you're only using one data frame, and I would say for my work, that's probably 85% of the time. I'm just using one data frame at a time, then just attach it. Makes your life much easier, quicker, simpler. Great. Life is good. So we're set, right? And of course, Madison, am I happy? Am I happy? Okay, okay. So I need to save it. And I go into my code and I'm going to name it 7B2 sample. And then I'm going to pick hurricane. And I want to put the year, semester. I'm cool. So there's a lot there, but it makes me happy. All right. So we did all that. That's the code for a student t-test. Student t-test that was created by the Guinness family, same beer company from Dublin, Ireland. Not only did it create the Guinness Book of World Records, it created the student t-test. The code, t.test, y-axis, x-axis. What I want you to do is I want you to identify which variable you're going to look at first. And I want an explanation for why that particular variable to address this question of have hurricanes changed as a result of climate change. It could be the frequency of tropical storms, frequency of hurricanes, frequency of major hurricanes, frequency of overall cumulative cyclone energy. One of those, do it, but identify why within your notes. And please write a scientifically appropriate result sentence in your notes. I don't know, you didn't tell me. You're coming up with the question. I give you an example, and I'll have to write down my question. And therefore, you guys can't use this one. As the number of major hurricanes changed since the inflection. Thank you. Global temperature. So I put down my question. Has the number of major hurricanes changed since the inflection in global temperature increases as a result of climate change? I showed you my code, 21 and 22. I did add a little piece of code, which is kind of a good idea. Data equals df. It will be important later, and therefore it's good to have it. I did t-apply because, well, my stats were annoying. And I kind of like annoying stats, but they're still annoying. And then I wrote the most beautifully wishy-washy result sentence that reflects the statistics. And I really want to put in the word strictly significant or technically significant. I'm gonna let you guys continue with 2 more minutes. And what we're gonna do is we're gonna stop. We'll actually start with this exact point on Thursday. And then we'll talk a little bit about the homework. Sign doesn't matter, so it just confuses the issue. The question was, do you report a negative t-value? And the answer was sign does not matter with the t-stat. Okay, ladies and gentlemen, gonna stop where you are. Again, we are gonna start with my result, your results in answering this question. One of the things I like about this is I literally have no idea what the answer is going to be before we start, because I don't know what you're gonna argue. I don't know what you're gonna decide on, and therefore I don't know what we're gonna find. My results are weird. They're annoying. I like that. But this is different. Sample, one sample test. It's gonna be your homework. This will be due not this Friday, the following Friday. You always have at least a week, and it just makes sense to keep it till Friday, so it's kind of standardized. Allows you to sort of review how to do the one sample, identify biologically appropriate null hypotheses, and this is a big point. Like when we were talking about where's a good starting point, there should be a logic for it. What is a good point for identifying a difference between historic and recent? There should be a good logic for it. Ideally, it should be based on the science. I think you guys made a good choice. I can understand like the point of Gore. I thought it was a valid point, but I think the point of NASA defining an inflection in terms of global temperatures is a more appropriate solution in this. Allow you to discriminate between parametric and non-parametric. Remember, we just had the one sample test, or we had the Wilcoxon sign rank test, but you have to make choices. How to visually represent the data appropriately, how to compose statistically appropriate, but biologically relevant result sentences. And that's a key. I don't want to hear you speak stats. It's not interesting. It's not our field. I want you to use stats. Stats are very interesting, very valuable because of what they tell us about our science. And then of course, create the function. The reason I waited for today is the data set that you are working with. You are working with snake data. And snake data is, I don't know how to read. But I know that these guys have pissed me off for a long time, and this is why you are playing with them. For reasons that are beyond my understanding, I had to do shark interviews once a week for like half a year, about a year ago. I don't study marine environments. But I was the guy that kept getting the calls to do the shark stories. Fine. There's incredible data sets about shark bites, provoked, unprovoked, time. What I want you to do is I want you to identify whether we have a change in the frequency of shark bites. I've given you the global data set that actually starts back in 1780 through 1999 as our old data relative to our new data. There are two things you have to do here. You have to come up with a biologically relevant null hypothesis. That would be the old data. But you have to decide whether all the old data are appropriate or not. And you have to make a decision about that. And you can look up any variety of things that you want to look at to make that choice. But you have to explain that choice, and it has to be reasoned in terms of why did you subsample this data to generate your null hypotheses. Your null hypothesis in a one sample test is defined by some biological expectation. You will then compare that to modern shark, where modern shark, this one is just purely arbitrary, 2000 and above. Totally arbitrary. But what is the historic data it's going to use? What are you going to subsample? What becomes your null hypothesis? And then you use that to do the comparison. The code, tiny. Logic, that can take time. Cool with that? Any questions with that? All right, I like to sum it. All of your answers can be, well, you can talk to each other. This is not like a closed book test, but they really should be your choice. So as an example, if Madison and Lucy talk to each other and Lucy's like, Madison has a terrible idea, Lucy should go her own way. You don't have to sort of convince each other. Come up with your logic. Cool? Have a good day. Oh, have a good afternoon, Zoom land. We'll see you on Thursday.